Hello, pupils. You're welcome to another wonderful edition of your favorite program, The Classroom in Your Home, a program organized by the Lagos State Government and packaged by the Lagos State Universal Basic Education Board, LASUBEB. The aim is to ensure that you are academically engaged in addition to what you're learning in school. I am Auntie Fumi, your English Studies teacher, and I have with me, as usual, your wonderful teachers.
Hello, children. I am your mathematics teacher, Uncle Agbaje, but you know me as the mathematician.
Uncle Popo is here, your general studies teacher.
And we also have our active sign language interpreter with us, Uncle Niyi. Together, we are bringing the classroom into your home. Please stay tuned. Hello, pupils. You're welcome to Auntie Fumi's class. And in our English Studies lesson today, we will look at the topic, doubles. Yes, that's the topic for today, doubles. It sounds so catchy. Of course it is. What are we doubling? Oh, in the course of the lesson, you will know more about the topic, doubles. But before we look at the learning objective for today, we will have the correction to our homework. Did you do your homework? Are you sure? Of course, I received some, but I don't know, maybe yours is among those submitted. So, in our last lesson, we looked at some words that have the silent letters in them. So, you were asked to write one example each of words that have silent letter T, silent letter D, silent letter P, silent letter G, and silent H. So here are my examples. Yes, you have something close to that. I trust you. You are smart children. And I want to say you are awesome. Totally. Good job, you. Let's cheer for you. Well done. Now to the learning objective for today's lesson. Today, I told you we're looking at the topic, doubles. By the end of today's lesson, you should be able to identify two words used together. Are you having an insight to what we are doubling now? Okay. You should be able to identify words together in sentences to give great emphasis. You should be able to identify two words used together in sentences to give great emphasis. Not only that, you should also be able to say the meaning of some doubles and use them in sentences correctly. You should be able to say the meaning of some doubles and use them in sentences correctly. So, let's begin. What are doubles? What are doubles? Doubles are two words used together in speech to give great emphasis. Let's say that together. Doubles are two words used together in speech or even in writing to give greater emphasis. Let's look at doubles formed by word repetition. We already said doubles are two words used together in speech or in writing to give greater emphasis. You want to emphasize on something, so you're using two words together to create that desired emphasis or emphasis. So we have examples of some doubles formed by word repetition, by repeating the same word. We have these examples. We have these examples. Look at this. By and by. We are repeating the same word. By and by. What does that mean? It means before long or eventually. We can have a sentence like, she'll get along by and by. She'll get along eventually. Are we together? So the word that is doubled is by. So we have by and by. Are you getting it? Well done. Another example is such and such. Such and such. What does this mean? We use this to refer vaguely to a person or thing that does not need to be specified. You want to refer to something or to a person that you don't want to specify. You can say such and such. We have so many goods to be sold by such and such a date, because you don't want to specify that particular date. So the word that has been doubled here is such, such and such. Are we together? Now let's look at round and round. Round and round. That is moving in circles. Moving in circles. Round and round. It all keeps going round and round in my head. You are using that to talk about, to say or to specify something that you cannot stop thinking about. It all keeps going round and round in my head. That means I couldn't take it off my head. I keep thinking about it. Are we together? Okay. Here is another example. Year and year. Year and year. That is talking about each year. Something that happens gradually each year. Look at this example or the sentence. I said, this output has increased year by year. What we have in 2020 is different from what we're having in 2021. Year by year. This output has increased year by year. That is talking about what happens gradually each year. Are we together? Still on the topic doubles. Are you learning at all? Okay. Another example is over and over. O-V-E-R and O-V-E-R. Over and over. What does that mean? Repeatedly. Repeatedly. If we have a sentence like, please listen to the lesson over and over again, it means you should listen to the lesson repeatedly. So the word that has been doubled here is over. Over and over. And it means repeatedly. So and so. So and so. That is maybe a person or a thing whose name the speaker does not need to specify, or does not know the name, or does not remember the name. You can just say so and so, because the name is not remembered, it's not known, or does not want to, it doesn't want to specify the name. Let's have so and so as a speaker next week. Mr. So and so should be the speaker next week. Maybe because I don't remember the name, or maybe because I don't want to specify the name. Maybe there are some people there and I don't want to mention or reveal the name yet. So we used words like so and so. Now, there are some doubles formed by repetition of meaning. The first examples that we looked at is repetition of word repetition. Now, you now say a word and you now repeat the meaning of that word. You form doubles doing that too. So we're going to look at doubles formed by repetition of meaning. Let's continue. Look at this word, this doubled word. Far and away. Far. What does it mean? When we say something is far, it is as close as saying it is away, not close to you. So, far and away, they are words formed by the repetition of the meaning of one of the words. Far and away. We can use this when comparing something, and it means by a very large amount. Is far and away the most accomplished player? That's a sentence using far and away. Is far and away the most accomplished player? That means within us here is an accomplished player. Away, abroad, far away, beyond where we are now, is also the most accomplished player. So we form these doubles by using the word and the meaning. Far and away. Beck and call. Beck and call. To be ready to react to their commands without a delay. When we use the word beck and call, it simply means to be ready to react to the commands, to obey the commands without a delay. No matter what, I am making an example now, no matter what time of day it is, she is always at his beck and call, always ready to obey the commands, always ready to run errands for him. She is always at his beck and call. So another example of doubles is beck and call. Are we together? Ways and means. Ways and means. That simply means methods and resources for achieving something. Ways and means mean methods and resources for achieving something. Let's look at that sentence. The company is seeking ways and means of safeguarding jobs. The company is seeking ways and means of safeguarding jobs. That means that the company is seeking for methods and resources for safeguarding jobs. So, the meaning of ways and means is methods and resources. Another example of doubles is odds and ends. ODDS and ENDS, odds and ends. When we say odds and ends, it simply means miscellaneous articles or remnants. It means what? Miscellaneous articles or remnants. Here is an example. We bought batteries for the radio and a few other odds and ends. After buying batteries for the radio, we bought other articles. We bought other articles. That is what we meant by saying we bought batteries for the radio and a few other odds and ends. It is activity time. Today we've been able to look at doubles. And we've identified two different types of doubles. Doubles that are formed by repetition of same words and doubles that are formed by repetition of meaning or very close in meaning to the words. So it is time to evaluate and check how attentive you have been in the course of this lesson. For your evaluation, please use the following doubles in sentences. Use the following doubles in sentences. Number 1, so and so. Number 2, ways and means. And number 3, far and away. So and so formed by the repetition of the same word so. Ways and means and far and away formed by repetition of meaning of words. So you have 30 seconds to write 3 sentences and your time starts now. Eyes on me. Eyes on your teacher. Well done. By now you ought to have given me 3 simple sentences using the following, this given doubles. So and so. Ways and means. Far and away. Of course, Antiphon is aware of the fact that you cannot give me the same sentence or sentences. So, you have different sentences. Here are my sentences. So and so. Mr. So and so gave her the money. I didn't want to specify that name. Or maybe I forgot the name. So and so. Mr. So and so gave her the money. Ways and means. There are ways and means of settling disputes. There are ways and means of settling disputes. And for far and away, I have this sentence. He lives far and away. At times it's here, at times it's not here. So he lives far and away. So I have 3 sentences. And I believe you do too. So well done. And I want to celebrate you with this chair. Good job, you. For your homework, you are to find the meaning of the following doubles. I'm going to give you 2 doubles. Find the meaning. Neck and neck. Fast and furious. Neck and neck. Fast and furious. In the next 10 seconds, capture this assignment, and I will be back for the next segment. Well done. Yes. Make sure you do your assignments, submit promptly, and indicate your name, your school, your class, and your local government education authority. That is the only way by which you can be identified and rewarded accordingly. On that note, that's it for today. I believe you had fun learning today. Today we looked at the topic doubles, and we looked at some words that are doubled with the same word, and we have another word that you have word that is similar in meaning to it being doubled. Yes, being used as the second part. We have come to the end of the English Studies lesson for today. Yes, we had fun learning today. And on that note, I hand you over to the mathematician, Uncle Agbaje, for a beautifully packaged mathematics lesson. Before I go, I want to remind you that Auntie Fumi is always proud of you. Bye.
Hello, children. You're welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Uncle Agbaje. Today in mathematics, we are not quite done with capacity yet. We will be looking at operations on capacity, how to add, subtract, multiply. It may not be as easy as you may think it is, but then, trust me, it is also not difficult. Today is Monday, and as is our usual practice on Monday, we'll begin with a mental exercise which we call the Math-a-thon. You will have 1 minute and about 12 questions. There is a pattern to this. If you can discover it, you will finish on time. Begin. Alrighty then, I believe that you are done by now. Did you discover the pattern? Well, let's see what the answers are together. 4 times 15 is 60, and here you still have 4 times 15 and then a 0. So you just get your answer here and then add an extra 0. That's why you have 60, 600. 17 times 3 is 51, 17 times 30 is 510. And what have we tried to achieve with this math-a-thon? Multiplying numbers that have zeros. Very easy. Just multiply the significant digits and add an extra 0 at the back. I hope you were able to get all at this time. Well, you are very smart, my friend, and I trust that you are making progress with the math-a-thon. Now, Let's look at the correction to the last homework on capacity and volume. The base area of a cylindrical drum is 450 centimeters squares and the height is 220 centimeters, the drum. It is half filled with water. How many liters of water are in the drum? Okay, so let's just get right into it. What do we know? We know that the base area of the water is 450 centimeters squares, and that is because the water is in a cylindrical drum. It will take the shape of the drum. So the base of the cylinder and the base of the water are about the same thing. So the base of the water is 450 centimeters squares. Remember our work on volume? When you know the base area, you don't need to use pi r squared again. You only multiply by the height. But what is the height of the water? We know that the height of the drum is 220 centimeters, but the drum is only half filled with water, so the height of the water will be half the height of the drum. Okay? So if the drum is 220 centimeters, half of that will be 110 centimeters. So now to find the volume of the water, we know the base area of the water, and now we know the height of the water, not the drum. Then we'll multiply them together, base area times height. Now, I don't need to add the zeros when I want to multiply. 45 times 11, using our shortcut, we will get 495. Then we'll add 2 zeros, and we'll have 49,500. I'm sure you multiply this, so I won't waste too much time showing you how. Now the volume of the water is 49,500 centimeter cubes. But the question says how many liters. It didn't say what is the capacity, what is the volume of the water. It's asking for the capacity. How many liters? So we have to use that relationship. We know that the volume of the water is 49,500, but 1,000 centimeter cubes is 1 liter. So for 49,500, we will have to increase 1 liter rather in this ratio, putting the bigger number on top. That is 49,500 divided by 1,000 multiplied by 1 liter, and by the time we cross out 2 zeros, we have 495 divided by 10, which of course means that the decimal point, which is on the right by default, will move back 1 time because there is 1 zero here. And then we are left with 49.5 times 1 liter. Let's see whether we're correct so far. 49.5 times 1 liter, and of course that is 49.5 liters. Therefore, there are 49.5 liters of water in the drum. Is that what you got, my friend? Of course you did, because this one was quite easy, but I will still celebrate you nonetheless with a chair. Now let us move on to today's work. Today's work, very easy. Addition, subtraction, multiplication, division. Not the way you know it, but still the same operation. By the end of the lesson, you should be able to perform addition operations on capacity of different graduations. You should be able to subtract capacities of different graduations. You should also be able to multiply capacities of different graduations. Without wasting time, let's go right into it. Addition of capacities, just an example. The capacities of 2 different buckets are 7 liters, 80 centiliters for one bucket, and 12 liters, 72 centiliters for another bucket. What is the combined capacities of these 2 buckets? Just as if you want to fill a drum and you have 2 buckets, these 2 buckets together, how much water can they hold? That's the kind of problem we're trying to solve here. So what is the combined capacity of these 2 buckets? Will it be more than the drum you want to fill, or will it be less than? So to find the combined capacity, when you're adding capacities, especially when they have different graduations, liter, centiliter, or milliliter, then put the headings for liter and centiliter, which is what we need in this case. Add the liters together, add the centiliters together, and then let's see. The first bucket has 7 liters, 80 centiliters, and the second bucket has 12 liters, 72 centiliters. So we just add the liters to the liters, add the centiliters to the centiliters. But we will begin from the centiliters side, and that is because by the time we finish adding the centiliters, it is possible that we have spilled over into the liters. Remember that 100 centiliters make 1 liter. So by the time we add the centiliter, it is possible we have more than 1 liter. Then we have to take 1 liter out of what we have and regroup it to the liter side. So let's begin. We have to add them together. Now, when we add 80 to 72, of course, 0 plus 2 is 2, 8 plus 7 is 15. Now, we have 152, and 152 is already in excess of 100 centiliters, because 100 centiliter is 1 liter. Luckily for us, this is the unit, this is the tens, and this is the 100. This means 100. So we just take this one normally as we carry one, like you say. So we regroup one to the liter side. This one is the extra because this one means 100, and in this case, 100 centiliters. So 100 centiliters make 1 liter. So you take 100 centiliters and take it to the 1 liter. And so we will have that one go over to the other side. And so instead of writing 100, it's just 1 liter. 100 here is 1 unit liter here. 1 plus 7 is 8. 8 plus 2 is 10. Regroup 1. 1 plus 1 is 2. Specifically, 1 plus 7 is 8. 8 plus 12 is 20. And then we've gotten our final answer. It would have been less than correct if we had said 19 liters, 152 centiliters, because 152 centiliters already has, is already in excess of 1 liter. So you just regroup the liter and you can add up the liters appropriately. So the combined capacities of the 2 buckets is 20 liters, 52 centiliters. Subtraction of capacities, let's see. A tank had 273 liters, 289 milliliters of water. A tank had 273 liters, 289 milliliters of water in the morning. Now, Z used 123 liters, 752 milliliters for her laundry. How much water was left in the tank? What kind of operation will this be? Of course, it is subtraction. So let's just go right into it. So what do we know? Now we're going to be working with liters and milliliters. How many milliliters make 1 liter? Of course, 1,000 milliliter make 1 liter. That means here we will be having 3 place values as against 2 for the centiliters. So before the laundry, the tank had 273 liters, 289 milliliters. So I put 289 under milliliters, 273 under centiliters. For the laundry itself, how many liters of water was used? 173 liters, 752 liters. And of course, this is a subtraction operation. So we just subtract. Now, we will not subtract one by one like we normally do. We subtract milliliters first and then liters later. So observe that 289 is less than 752. So that means that we cannot subtract 752 milliliters from 289 milliliters. It's not going to work out. So we are going to have to borrow 1 liter from here. And that 1 liter will bring it over to the milliliter side. 1 liter means how many milliliters? It means 1,000 milliliters. So we have to borrow. And when we borrow 1 from 273, we are left with 272. But that one that we borrow is actually 1,000. And it's going to occupy the 1,000 place here. See, unit, tens, hundred, thousand. So it's enough to just bring the 1 and put it by the side. Now we can subtract. 9 minus 2 is, we should get 537 because 9 minus 2 is 7, 8 minus 5 is 3, 12 minus 7 is 5. Now we're done with that point that we have to subtract here. Now by the time we subtract 173 from 272, 272, 173. Borrow 1 from here, I have 6. 12 minus 3 is 9. Borrow 1 from here, 16 minus 7 is also 9. And that means we're going to be getting 99. So that's 99 liters. So the amount of water left in the tank is actually 99 liters, 537 centiliters of water. The amount of water left in the tank is 99 liters, 537 centiliters. Okay, here is another example, but this one will be, yes, on multiplication of capacities. On average, a restaurant uses 8 liters, 48 centiliters of vegetable oil every day. On average, a restaurant uses 8 liters, 48 centiliters of vegetable oil on a daily basis. Now, if it opens 6 times in a week, calculate the average weekly use. Okay, 6 times in a week, and we know how many liters is used in a day. So for 6 days, it will have to be that usage, that daily usage in 6 places, that is multiplied by 6. So let's go and see how we multiply liters. So again, we are given the capacity as liters and centiliters, so we have to put 8 liters, 48 centiliters for the daily use. 8 liters, 48 centiliters. Now, how many times does the restaurant open? 6 times, and that means we have to multiply by 6 to get our weekly usage. So how do we multiply? Well, we have to multiply the centiliter part first, then we multiply the liter part first, after that. Now, if we have any spillover centiliter into liters, we regroup that and add it to the liters. I'll take that again. Multiply the centiliters, get your answer. Multiply the liters, get your answer. And check if the centiliters have spilled over into the liters, and then regroup and add appropriately. So let's see. 6 times 48. So 6 times 8 is 48. We regroup 4. 6 times 4 is 24 plus 4, that is 28. And so 6 times 8 here is 48. Okay. So we have 48 and 288. And 48 liters, 288 liters. But it is not yet over. We have to check whether we have spillover into the liter side. And of course, centiliter is 100 centiliters make 1 liter. In this case, if you put 100 tenths and units, you already have 200 here. You already have 200 here, and 200 centiliters means 2 liters. So just bring it over to the liter side. See, and then you add 48 plus 2, you get 50. And that means that the weekly use of oil in that restaurant is 50 liters, 88 centiliters. Must be a big restaurant. Okay, so just focus on what we have done. We multiply the centiliters, and then we multiply the liters, and then any spillover liter, we bring it here and add accordingly. Now, your turn is now to prepare a meal for 2. Z uses 856 milliliters of water from a filled 2-liter bottle. You know, she has a bottle, a 2-liter bottle that is filled up, and she uses 856 milliliters of water. How much water is left in the bottle after Z is done cooking? Begin. Alrighty then. Progress made. Of course, I'm sure you found this very easy, because we know that 1 liter is 1000 milliliters. So we have to subtract. This is a subtraction operation. So before cooking, it was a bottle of water that had 2 liters of water. So that's 2 liters, no extra milliliters. Then we have to subtract 856 milliliters for cooking. So beginning from the milliliter side, it is not possible to subtract 856 from 0. So we have to borrow 1 from the liter side, and we're left with 1 liter. and this one becomes 1000 milliliters. Now we can subtract, and when we subtract 856 from 1000, let me see here, bottom one from here, you have 0, 10, then you have 9, 10, then you have 9, and then you have 10. 10 minus 6 is 4. 9 minus 5 is 4. 9 minus 8 is 1. And that should be 144 milliliters. And then here we have 1 liter. So let's see whether we are correct. 1 liter, 144 milliliters. Yes, 1 liter, 144 milliliters, my friend. Did you get this right? Excellent job. You have another for practice in the homework, which is, of course, coming very soon. But the summary of what we have learned today is that when we want to add, subtract, or multiply capacities, we have to put them under the appropriate heading, either liters, centiliters, liters, or milliliters, and then carry out your operation. By the end of the day, when you're done, check if you have any spillover from the lower unit and add it to the higher unit. And remember the relationship that 1 liter is 1000 milliliters, 1 liter is 100 centiliters to work with. Keep that in mind as you attempt solving this homework. Capture this in 20 seconds, and I'll be right back to sign off. Alrighty then, we have come to the end of the mathematics lesson for today. I believe that you learned something new and you're willing to implement them during your free period. Now it's time for me to hand you over to Uncle Popo for the general studies lesson, which promises to be interesting. Till I come your way in the next class, remain wonderful mathematicians. Bye bye now.
Hello pupils, you are welcome to General Studies class. I am Uncle Popo. Uncle Popo is here. Good, I can see you are there. We are here together. Excellent. 100% attention is what I want you to give me in today's lesson. Our subject for today is basic science and technology. In our last lesson, we talked about temperature. You were told that temperature is the degree of hotness or coldness, of a place. And you were told different types of thermometer and uses of thermometer. You were told that we have the clinical thermometer and so on. So today we are moving on to new topic, and it's topic we are very familiar with, and that is electricity. Say that. Electricity. I know talking about electricity, some just believe that we are only referring to the light we get maybe through your bulb, your fluorescent, and that's what you understand by electricity, or the power supply that is being supplied by the PHCN. That's when you think what we regard to as electricity. But today we shall study more and look at what we really call electricity. The learning objectives for today, by the end of the lesson, you should be able to define electricity, and you should be able to state types of electric current and electricity. Likewise, you should be able to describe the flow of electric current. So listen attentively as we begin. Electricity is the flowing of electrons in a circuit. Electricity is what? The flowing of electrons in a circuit. When we say electrons, what are we talking about? Because I know some are looking at me that, what do we mean? Electric current is defined as the rate of flow of electric charge. When you say you have maybe we have copper wire or in a socket, and maybe you've heard it before that you say there is current in this thing. That means they are talking about there is electric current. What do they mean? They are saying that there is a rate of electric charge in that where they are talking about. It could be through copper wire, it could be in your socket at home, that they will say there is current there. That means there is flow of electric charge in it. So that is what we are referring to, electric current. Now let's look at types of electric current. You know, talking about electricity, we are talking about electric current, and we are having two types of current using electric circuits. What are the two types? The first one is direct current. Say that. We have direct current, and the second one is alternating current. Say that. These are the two types of electric current that we have: direct current and alternating current. When we say direct current, what are we referring to? This is just an example of direct current. I know some will have seen this before, and some will have done this type before, where you have your battery and you have bulb connecting that your wire to it at the positive and the negative, and you get your lights, your bulb being lighted. So when we are saying direct current, what are we talking about? This is the current derived from cell or battery, like you were shown in that slide before this. The current derived from cell or battery. When we say cell or battery, we are referring to maybe your car battery or your touch battery. Like you have this touch battery, is the current derived from battery cell or car battery that's using connection to give you certain power. So when we talk about a cell, what are we talking about? C-E-L-L. A cell is a single unit that converts chemical energy into electrical energy. Like the slide that I showed to you before, the battery, the cell we use, is converting that chemical energy to electrical energy. You know, it's lightning the bulb, and that is conversion from chemical energy into electrical energy. So a cell is a single unit that converts chemical energy into electric energy. Likewise, we have this is just another one. A cell has a positive and negative terminals. I showed you that before. When you see a cell, it must have the positive and negative terminal. Like you can see in this picture here, this is a cell, the positive terminal, the negative terminal. So moving on. Now, when we say battery, what are we talking about? A battery is a collection of cells. A battery is a collection of cells. We have talked about cells, but when talking about battery, we are talking about the collection of cells. That's what we mean by a battery. What are the types of cell? We are having dry cell. We also have wet cell. When we say dry cell, what are we talking about? Dry cell is a cell that contains only solid or paste materials, like your touch battery. The battery you put in the touch, that's talking about the dry cell, because it contains only solid or paste materials in it. That is dry cell. Talking about, this is just a typical example of dry cell. This is it. Still on dry cell, they are also called primary cell. They are also called what? When you hear primary cell, it's still talking about dry cell. Why? Why do they call primary cell dry cell? It's just because they cannot be recharged. You can't recharge those cells that I've shown you before, cannot be recharged. Let me show it to you again. Like this kind of cell cannot be recharged, and they are regarded to as primary cell or dry cell. Now, talking about the second type of cell, that is wet cell. It's a cell or battery that has liquid as one of the materials contained in it. Wet cell is a cell or battery that has liquid as one of the materials contained in it. Like the other cell, the dry cell I showed to you, I know maybe you have seen where they try to break maybe one of the batteries of your touch before. You can see that what you have there is dry. It cannot be liquid like the one we are talking about here. Talking about wet cell, is a kind of cell that has liquid as one of the materials contained in it. Example here, very good example, is car battery. If you have seen the battery anywhere before, or your daddy's car, the battery used in such car, you see that is a kind of wet cell because it has liquid as one of the materials contained in it. It has liquid as one of the materials. An example is car battery. Don't forget I told you dry cell, and a very good example is the touch battery. Now, they are called secondary cell. Another name for the dry and wet cell is secondary cell. Why do they call those cells secondary cells? Is because they can be recharged. Don't forget, dry cell or primary cell cannot be recharged. Wet cell or secondary cell can be recharged. Example of primary cell or dry cell, your touch battery. Example of secondary cell or wet cell is car battery. So don't forget all that. And then let's look at the second one. You know, we have talked about direct current. Now we want to talk about alternating current. When we say alternating current, this is the current derived from other sources. It's just the kind of the current you derive from your generator, your electricity generation and distribution companies, and so on. We are talking about electricity, and I told you that it's not only the kind of current we derive from our generator or from the PACN that we regard to as electricity, even the ones from your battery, and it makes certain things work, it's also electricity. But mostly we believe that the power gotten from generator or the one your PACN distribution company is what you regard to as electricity. It goes beyond that. Even from the batteries is also electricity. So the current derived from other sources like your generator, electricity generation and distribution companies are alternating current. Example like the transformer, you know, all the supply, your power supply, you must have a transformer maybe in your street or that belongs to your community that will generate the power, or from generator. So there are good examples of alternating current. This is what I'm talking about. This is alternating current. The first one we talked about is direct current, and we talked about cells, your touch battery, your car battery, and this is alternating current from transformer, kind of current you derive from that. Your generator are alternating current. Now let's talk about types of electricity. There are two types of electricity. We have static electricity and current electricity. Static electricity and current electricity. Talking about static electricity, what are we saying? It's the type of electricity that does not involve the flow of current. It's the type of what? Electricity that does not involve the flow of current. It does not involve the flow of current. This is a good example, but let me give you this example. For example, the rubbing together, because this is very common, the rubbing together of a balloon and a clothing material can make the balloon to be attracted to a ceiling. I know after this class you can try that. So the rubbing together of a balloon and the clothing material can make the balloon to be attracted to a ceiling. So that is, we are talking about static electricity, and I know you have seen this type before. This attraction is caused by charged particles called electrons. These electrons do not flow through a circuit, therefore it is static. This kind of static electricity does not involve the flow of current in a circuit, because your balloon and your clothing materials, when rubbed together, attracting to a ceiling, does not involve any flow of current. So that is static electricity. Now let's look at the current electricity. When we talk about current electricity, what are we saying? This is the flow of electrons from direct or alternating source through wires and other materials that make a circuit. Your copper wire or other conductors that attract power from one source to another. That's the flow of electrons from direct or alternating source through wires and other materials that make a circuit. You can see here that we have the wires. Let's regard this as the copper wire connecting to this, and it's giving us light here. So that one involves the flow of current in a circuit. That is what we say current electricity. It's different from static electricity that does not involve the flow of current, current electricity, that one involves the flow of current in a circuit. So it's time for evaluation. So I have just 3 simple questions to test you and see how you have given me your 100% attention in today's lesson. The first question, define electricity. Second one, list 2 types of current used in an electric circuit. And third one, mention 2 types of electricity. You have just 40 seconds to attempt this. Your time starts now. Eyes on me. Uncle Popo is there. So I believe you are still there. And when you are still there, let's mark together. Electricity is the flowing of electrons in a circuit. That's just the meaning. The flowing of electrons in a circuit. 2 types of electric current. Direct current, alternating current. And the types of electricity, we have static electricity that does not involve the flow of electric current, and current electricity. These are the 2 types of electricity. So, which one did you get right? Okay, you got everything. Wow, you deserve to be given a cheer. We have come to the end of today's lesson. Until next time, next lesson, Uncle Popo says, keep on studying. Bye.
My wonderful pupils, we have come to the end of another beautiful edition on the classroom in your home.
It has been like we should not end today's lesson, but of course, time is not our friend. But we have had fun, hoping that you have as well. And you have learned new things in mathematics, in English studies, and of course in general studies. Now, you can keep Auntie Fomi, Uncle Agbaje, and Uncle Popo with you even after we're gone. The only way you can do this is by doing the online assessment that we have structured out for you. You can access this online assessment using the link bit.ly/LASUBEB-tests. That is bit.ly/LASUBEB-tests. Remember, that's our way of knowing how well you are performing so that we can build more fantastic lessons for you.
Taking the online test is based on if you have access to either your daddy's, your mommy's, your uncle's, or your auntie's Android or smartphones. If not, there's no problem. Just send your questions, your comments, and your homework to 081 50 86 5663. Please do not call that number. SMS and WhatsApp messages only. And when you're sending in your homework, make sure you indicate your name,
your school,
your class,
and your local government education authority. That is the only way through which you can be identified and rewarded accordingly.
We believe you enjoyed today's lessons and the previous ones. All these lessons are on Lagos Subeb YouTube channel for you to watch over and over again. Just subscribe to Lagos Subeb YouTube channel in order to get notification when new videos are uploaded. The classroom in your home could be watched live on Facebook, the same time airing on television through the page showing on the screen.
Until our next lesson, when we shall meet again on another beautiful edition of the classroom in your home, make sure you do your homework.
Wash your hands regularly.
Keep studying hard, but above all,
stay safe.
Because at LASUBEB,
we leave no child behind.